Hi guys, welcome back to the channel. Let me know if the sound is working before we make a start on this paper 2. So we've got here this one, oh, it actually doesn't say on it, does it? This is the November, well you can see obviously on the title of the live. 2022, paper 2H. That's the one we've got here. Yeah, you can always watch this later. Once we've finished the live, it will upload anyway, so you can always come back and watch it if you want, tomorrow or another time that suits you. Yeah, we'll be doing lives during half term as well, definitely. So obviously make sure you do have your calculator for this one, and not just your phone, your scientific calculator, because obviously that's the one you'll have in the exam. You need to get used to it if you haven't already. So we're going to just jump right into it then. If you need the paper, it is linked in the description, and so is the mark scheme as well. You can have a look at that if you want to. So we've got here, the scatter graph shows information about the amount of rainfall in millimeters and the number of hours of sunshine for each of 10 English towns on the same day. One of the points is an outlier. Write down the coordinates of this point. So it should be pretty obvious, the scatter graph ones. I mean, in this case, obviously it's the one down here, right? Because otherwise you can follow this kind of trend line. So it's not the one at 6, right? That one does kind of follow the trend. It's this one over here at the 2. So yeah, exactly, 2 for X, and then you can see here, that's 1 for Y, so 2, 1. Yeah. I think there's also part B that we might need to go back, part C as well. So, ignoring the outlier, describe the relationship between the amount of rainfall and the number of hours of sunshine. So I'll just show you again. So we just need to describe the relationship. It's kind of, obviously there's loads of different answers for this one, given that it is a worded question. But yeah, they will allow you to say negative correlation if you want to describe the correlation. The main answer they gave actually wasn't negative correlation, but they did say they would accept that. The main answer was something like along the lines of, as the amount of rainfall decreases, the number of hours of sunshine increases, or if you wrote it the other way around, that's also fine. So you can literally describe it as well. So either negative correlation or literally describing the context. As one decreases, the other increases, for example. But negative correlation, I guess, is the easiest thing to write, isn't it? Correlation. There we go. So part C, on the same day in another English town, there were 7 hours of sunshine. Using the scatter graph, estimate the amount of rainfall in the town on this day. It's 2 marks. So in this case, if you've got a scatter graph and they want you to estimate something, you have to draw a line of best fit. Okay, so you have to draw a line of best fit. Obviously, they'll give a small range of possible answers because everyone's line of best fit will be slightly different, but it should be, you know, not too far off what I'm about to do. So normally with a line of best fit, I try to have as many, more or less as many of these marks above the line as below, or if you can cross through as many, you know, something like that. So I think I would probably do something like this. That was my line of best fit. Yeah, they're quite scattered in this case, aren't they? So do you see how I've got, you can kind of ignore the outlier one, but I've got 1, 2, 3, 4, 5, 1, 2, 3, 4 above, 5 below. It's kind of, you know, more or less even, isn't it? And then that's when I can go across. So they said 7 hours. So again, just be careful of the scale of the graph. 7 hours. And then down. So in this case, I've got 3. That was what I got. So I'm going to write down 3. However, they have said their range of possible values is between 3 and 4. Anything between 3 and 4. So I was very close to one end of that limit. You might have drawn your line of best fit maybe a little bit further along, closer to these other points. Also fine. So you see you've got a fair amount of space here, haven't you? This is kind of your range there. So yeah, you've got a bit more of a range to give your answer for. But yeah, make sure you do draw the line of best fit, right? You need to draw the line of best fit and leave it there so that they can see that you've done that. So that was a nice 4 marks to start with. Question 2, we then have the front elevation and the plan of a solid are shown on the grid. On the grid, draw the side elevation of the solid from the direction of the arrow. So the plan is like above, like the bird's eye view if you're looking down at it. And obviously the front elevation is if you were just stood in front of it looking straight ahead. So now we want to know what it looks like from the side. So you kind of have to try and visualize what it looks like as a 3D shape. And then, you know, if you were stood on this side looking at it. So what I got, you can obviously draw it anywhere on the grid just as long as you've got enough space, is you can see from the plan how wide the shape should be, because technically, my pen gone, you're still looking, I guess, from that direction, aren't you? So that the width of it would be 3 squares across, wouldn't it? So that's the first thing, 3 squares across, and then you've got to figure out how tall it is. Well, that's obviously this one here, isn't it, based on the front elevation, the tallest part. Yeah, exactly, so that should be 5 squares. So 3 by 5, 1, 2, 3, 4, 5. Just about gave myself enough room. Like that. Obviously, you would join it up a lot better than I would. That's kind of the basis shape. Now I'm just going to check the mark scheme though, because I want to see exactly what they've written. Sometimes you can put lines through it as well, can't you? Let me just grab the mark scheme so you guys can see. There we go. Here we are. You can see they've drawn a little diagram here as an example. Can you see that there? So obviously they've said fully correct side elevation 5 high, 3 wide. Their example is that if you did draw the lines as well, then that's fine. Yeah, so you can draw these lines. I don't think they're that, I don't know, it doesn't really specify that they're that fussy about the lines. So if you didn't, it sounds like you'd be okay. And let me just see. For a rectangle 5 high, 3 wide, or correct side elevation in wrong orientation. It's not very obvious, is it? I would probably draw the lines, I think, just to be safe. Maybe the dotted one's not so important, but I would probably draw the lines to show, you know, this height and then this height here. So as you said, at 3. That's probably what I would have drawn, yeah. How do I know it's 3 wide and 5 tall? Well, it's 3 wide because I was saying that the plan, this is the width, isn't it? This is this side. And then the height is this thing here, as in the total height. Okay? So I'm just trying to picture that whole thing in my head as a 3D shape, and then what it would look like from the other side if you were just to flatten it into a 2D kind of image of it. But yeah, 2 marks for that, for the plans and elevations. So question 3, we've got here are the first 5 terms of an arithmetic sequence. So in other words, a linear sequence. Find an expression in terms of n for the nth term. You might do this differently to me. I just figure out obviously the difference between them, so it should all be the same. So we've got 6. Now that's the number that goes in front of the n. Then I tend to write out whatever that times table is. You can just write it out for a few of them. You don't have to do all of them if you don't want to. And then I say, well, okay, I'm currently at, for example, 6. How do I get to 7? Or I'm currently at 12. How do I get to 13? So on. It's what you're figuring out is what do I need to add or subtract after I've done 6n. Obviously, in this case, you'd have to add 1, wouldn't you? 6n plus 1. That would work for all of them. Yeah, 6n plus 1. Okay. So then you've got a part B, the nth term of a different sequence is 8 minus 6n. So that one's like a decreasing sequence. So they've said, is minus 58 a term in the sequence? So there are 2 ways you can do this. I just think of it algebraically. If that's a term in the sequence, then I can put it equal to the nth term formula. Yeah, exactly. And then I would solve it. You can do a bit of kind of subbing in numbers and all that, but I just think that takes too long. I would just rather solve it. So I would probably add 6n just to make it positive over here, add the 58. I think that gives you 66. Divide by 6. N is 11. Now, obviously, if you get a whole number, then you can say yes. If you got a decimal, for example, then you would say no, because n has to be a whole number, doesn't it? So is it part of a sequence? Yes. Because it's a whole number. Yeah, I think that's the easiest way, but they have given other options on the mark scheme, so as long as you get to the point where you've said yes, then that should be fine. Okay, so we've got question 4. The diagram shows a plan of Jason's garden. A, B, C, O, and D, E, F, O are rectangles, so you can kind of see these two here diagonally. CDO is a right angle triangle here, and then AFO is a sector of a circle with center O, and you can see that this angle is 90 degrees. So it's basically a quarter of a circle, isn't it? Jason is going to cover his garden with grass seed. Each bag of grass seed covers 14 meters squared of garden. Each bag of grass seed costs $10.95. So work out how much it will cost Jason to buy all the bags of grass seed he needs. So obviously we're going to need to work out the area, right? That's kind of the general context. So it's effectively a compound shape because you've got 4 shapes there, haven't you? So you can start off with any of the ones you want. I think might as well start with the rectangles. They're a bit easier, aren't they? So we've got obviously rectangle, length times width. So one of them should be 77. You can obviously use the calculator, but some of this is not too difficult, is it? 9 times 7 for the other rectangle. I'm going to add these up at the end. Then the triangle. So I'll put that there. That's like the 2 rectangles. The triangle we've got, don't forget, is obviously half base times height or base times height over 2, whichever of those 2 you like. Obviously then you can figure out the base and height. So we've got 9 is this one and 11 is this one. 9 times 11, which is not, I think it's like 49.5. It's not a whole number. And then obviously then we've got the quarter circle. So we're just going to do, that was a horrible quarter circle. There we go. We're going to obviously do pi r squared, which is the whole thing, isn't it? The whole circle. What's the radius? The radius is 7. Can you see? 7. So pi times 7 squared, but I only want a quarter of that. So you do need to remember to divide it by 4. Oh yeah, you can times it by a quarter, exactly the same thing. Yeah, that's fine. Okay. So that one I think I would probably put into my calculator at this point. So we've got pi times 7 squared or 49. You can just put that in. Is that, you can write that down. Obviously it's loads of decimals. So I'd probably write it down as pi, and then obviously you know I'm going to add them up anyway. So 49 over 4 pi meters squared. So now I've got all of them. I've got all 4 parts. Obviously I'm just going to add all those together. So that's when I'm going to bring in the calculator. So I've already got the answer there for that quarter circle. Add 49.5, add 63, add 77, and you get this. 227.98451. Because we're going to be buying like whole bags, we can't obviously buy an exact amount of grass seed, can we? We have to buy enough bags. So I'm probably just going to round that to 228, just for right now. That's about 228 meters squared. And then we can look at this second bit here. Okay, each bag covers 14, so I'm going to take 228 divided by 14. You can still use the same answer from your calculator if you want the decimal answer. Just divide that straight by 14, which is 16.28. Now, obviously, I can't buy 0.28 of a bag. I have to buy the whole thing. Right? I have to buy the whole thing. So this would round up to 17. I would need 17 bags, wouldn't I? So that's like 17 bags, isn't it? Bags. And then the last thing is just, well, how much would that cost? So 17 bags multiplied by 10.95, because that's 10.95 for each bag. So now I am just going to take the 17. I'm not going to use the decimals. 186.15 is what you should get. And that one, I think it was an exact answer. I don't think they gave you a range. I think it was literally that, because obviously it has to be 17 bags. There's no kind of rounding situation there, is there? It is exactly 17 bags that you need. So you had to get exactly 186.15. And if I scroll down, that one was 5 marks. So I think that's quite nice, you know, not too difficult, but a lot of marks. So yeah, I feel like there's always some kind of, it seems for paper 2 or paper 3, there's always some kind of, whether it's area, volume, surface area, but something like that at the start of the paper. And it's normally quite a few marks though. And it's definitely normally got a context as well. You see how this was related to like a garden and stuff, it's got a context. So I think that's quite common from what I've seen. Okay, let me have a look for the area. Let's see. Where is it? Here. So you got mark 1 for correctly finding the area of at least 3 sections. So you get that mark right because you got the other 3, I'm assuming. For a method to find the number of bags required. Yeah, so then it kind of skips ahead, doesn't it? A method to find the number of bags required for one area or a combination of the areas. So that's the method. Do you see how you've got these things in like speech marks? Obviously, those are technically the correct numbers that you should have, but they're saying if you, let's say you got the answer wrong in part 1 but you carried it forward correctly, if that makes sense. So even if you inputted the wrong number but you did do the correct division, that would be another mark, even if you got the wrong ones. You got 49 over 16 pi. I don't know how you got 49 over 16. It should be 49 over 4. Because the only thing squared is the radius, not the 4. The 4's not squared. Then they've said for method to work out the total of all. I don't know why they do it in that order, actually. That's weird. So the fact that you've added them all together, even if they were wrong numbers, if you've added them all together, I think you get a mark for that, even if the numbers were wrong. Oh, where's the 3.5 come from? Because, let me come back. Because the radius was 7, not 3.5. You see? Because this is the center, isn't it? That's the center. So that is a radius, that's a radius. And you can see ED or BC are both 7. So 7 times 7, which is 49. Yeah. Just because that was the center. But yeah, if it was the diameter, you'd have to half it. But it wasn't in this particular case. Sometimes it is, though. Yeah. So if you added them all together, even if you added the wrong numbers together, it seems like they'll give it to you. This mark is dependent upon correct processes, right? You might have different numbers, but for method to find the cost, and then obviously your answer then has to be correct. Actually, this one seems pretty nice. I think even if you got the area numbers wrong, they seem to have given you 4 marks. Most of it's just the method, isn't it? Not necessarily the numbers. Obviously, at the end, you have to then get the right number. So, I don't know, you might have got, 3 or 4 for that one, depending. If you've, then added them all together, divided by the 14, times by the 10.95. Do you know what I mean? If you've done that, if you've done all the correct process, you might have got 4 marks. Yeah. So let's move on. Question 5. Actually, I'm going to make this a bit bigger. Why is that so small? Nope, not by zooming. Hang on, guys. Let me go back. I don't know why I made this one so much smaller. Yeah, it's not letting me zoom in for some reason. Anyway, so we've got question 5. Work out the value of x. Give your answer correct to 3 significant figures. This is obviously basic trig. Given that you guys, I don't think you had basic trig in the Edexcel paper 1, did you? So this could come up in paper 2 or paper 3 like this. So we've got, I tend to label 2 sides that are relevant. Obviously the 14.5 is relevant because they've given it to me. And then the other side that's relevant is the one I want to find out, which is the adjacent. It's next to the angle. So that tells me I need to use cos. I like to use the formula triangle. You can do it however you want. We're looking for the adjacent. So that means I need to do cos 53 times by 14.5. Obviously then in my calculator. And it's literally just that. Yeah, it's cos, exactly. So you should get that. They've also said to round it to 3 significant figures, so I'd round that to 8.73, because the 6 would round up the 2 to a 3, wouldn't it? 8.73. Now they do give, well, kind of a small range of answers, so if you didn't, it's basically if you didn't round it correctly, they'll kind of still allow it. So as long as you've got anything between these two values, then that's fine. But hopefully you would have obviously just rounded it correctly anyway. Then we've got compound interest. Compound interest is obviously one of those topics that's very, very, very common in paper 2, paper 3, because it's obviously a calculator one. You can get a range just because some people haven't rounded it correctly, if that makes sense. Do you see how, as in my answer was technically 8.7263 ... If they'd written down just the whole of this and they didn't round it, then I think they would have still got the answer right, is what they're saying. So they're allowing for the fact that you haven't rounded it correctly, which I think doesn't make sense, because if you've asked them to round it correctly, then surely that should be part of it. But yeah, normally they're not that worried about if you haven't rounded it correctly. So yeah, this is quite nice. This is also on, well, I think in this case, I don't think we even need the formula in this case necessarily, but the formula is on your formula sheet if you don't already know what it is anyway. Yeah, sometimes if they ask you to find the interest rate, you just have to set up the formula, put it equal to the numbers they've given you, and then rearrange it, basically. Okay, so this one we've got Ella invests $7,000 for 2 years in an account paying compound interest. In the first year, the rate of interest is 3%. In the second year, the rate of interest is 1.5%. So actually, it's only like as in 3% for 1 year and then 1.5% for another year. So it's not really compounding technically, is it? Because there's not multiple years. Work out the value of Ella's investment at the end of 2 years. So it's more like just multipliers, I guess. So you start with the 7,000, multiply it by, now I naturally just obviously have to convert them into decimals, but you have to use 1 because that's the same as 100%, isn't it? 100% as a decimal is 1, and then add 3%, so it would be like 1.03. That would obviously give you the end of year 1. You can just do it straight away into the same, like you could write down the answer to that and then do the second year, or you could just do it all in one. The second year would be 1.015. You can obviously write it as like 1 plus 3 over 100, blah, blah, blah. Like you could write it like that if you wanted to, but I just naturally put it into the multiplier. So it's kind of up to you how you want to format it. So let's see, 7,000 multiplied by 1.03, not just 1, ideally. 0.03 multiplied by 1.015. Just make sure you get that 0 correct in the middle, because it's not 15%, it is 1.5%. And then, yeah, you should get the exact answer. This one doesn't have any kind of rounding possibilities, right? Yeah, you can add 100 and then divide by 100, but I just did it. Like, that is what that is, isn't it? So 100 plus 3 is 103, divided by 100 is 1.03. So you can write it like that as well. I just did it, like, directly. So 7,318.15. That should be your exact answer. They haven't given a range for that, because obviously there's kind of no room for interpretation there, is there? Yeah, whatever method you use is fine, as long as you get this answer. I don't mind if you wrote it down differently to how I wrote it down. I just naturally did the multiplier in my head, because to me that makes more sense. You might find that it makes more sense to write this. Also fine. I think the formula says 1 plus, like for example 3. That's what the formula says. Also the same. That all of these are all the same things basically. So that's a nice 3 marks. Okay, we've also got then question 7. Here is the graph of y equals x squared minus 6x plus 4. The actual questions are on the next page, so I'm just going to have a quick look here. First of all, write down the y-intercept for the graph. You don't even technically have to look at the graph. It is just that number at the end, but obviously you can come back and see it's 4. Okay, so that one would just be 4. It will allow it if you put the coordinates, like if you put 0, 4, also fine. If you just put 4, also fine. Write down the coordinates of the turning point. So that one you just go back, and I think you had a question like this in part in your first exam anyway, so they probably won't ask this again, but you would just look at it, right? So obviously that's 3 there on the x, and then on the y, minus 5, isn't it? So 3 minus 5. Obviously, you've got to get the numbers the right way around as well. Why is there no coordinate brackets for the first one? Because they just asked for the y-intercept as in the y coordinate, if that's what you mean. I don't know if that's the question you're asking. Because obviously there's coordinate brackets for this one. And then part C, use the graph to find estimates for the roots of x squared minus 6x plus 4 equals 0. So roots is another way of saying solutions. It's a synonym. Sometimes they say roots, sometimes they say solutions. It's basically saying what is x. X equals, obviously you would get 2 because it's a quadratic graph, you're going to get 2. And then where are we looking? Well, not the 4, we're looking at this one, right? That's when y is 0, so obviously the x-axis. If you get a different number there, you would look at wherever that number is on, across. Obviously here, in this case, we're looking at the x-axis, so that's here and here, so you need to read them off. I normally just do it to 1 decimal place, so just as close as you can get. They do give a slight possible range for these answers, because obviously it's not literally exact, but I would have said, I think I would have said 0.8 for that one, and I would have said 5.2 for this one. So then x is 0.8 and 5.2. I'm not writing the y solutions. Yeah, I think they would allow you to write that, but I'm not writing the y solutions because technically y is 0, isn't it, as you've written? I already know that y is 0 based on the question, so I'm only writing x, but I think they wouldn't mind if you did. Let's get our... Not that, let's get our... mark scheme back. So here, do you see they've given you a slight range? So as long as you get anything between these two, then that's fine. If you put it to 2 decimal places, that's also fine. What else have they said? For a correct method, e.g. marking both intercepts on the x-axis, or for one correct solution. So if you get one of them right, you'll get 1 mark. If you obviously get both of them right, you'll get the 2 marks. They've said here they'll accept it if you give it as a coordinate. So as you've said, in coordinate format, obviously your numbers are different, but that's fine. You're still within the range. They said they'd allowed the coordinates, so yours is, you would get the marks for yours. So I've just like listed them. You could say this or this and this. I've just put a little comma, like as a list, not as a coordinate, as a list. So it's either 0.8 or 5.2 in my case. You put 0.75, 5.25. Also, that was fine. It was within the range, wasn't it? So that was okay. So you'll get the marks for that. So that was quite a nice question, but I think you did have something similar to that already anyway, didn't you? Okay, question 8. Chanda buys a necklace for £120. She sells the necklace for £135. Work out her percentage profit. That's just the same formula as percentage change, isn't it? So you'd want to work out the difference, which is literally the profit. So subtract them. Obviously you can see what that would be, but I'm just writing it down to get some method marks. And then you divide it by the original. So the original, if you think about timeline, is going to be that she obviously bought it before she then sold it. So the original is always the cost or whatever she's bought. And then obviously you're going to times it by 100 to make it into a percentage. And that gives me 12.5%. Yeah, difference divided by the original amount times 100. It's the exact same formula, just obviously relate it to the context. Obviously that's an exact answer. I'm sure they'd allow, if you put it as a fraction, they'd probably allow it, right? They'd probably say or equivalent, but as long as it's, means 12.5, then that's fine. Question 9. So here are the equations of 2 straight lines. Oscar says that these lines are parallel. Is Oscar correct? Must give a reason for your answer. Oh, you want to see the mark scheme? Yeah. So 1 mark, there's obviously different orders that you could have done things in. They said 1 mark for the difference in our case, and then the second mark for then converting that into a percentage. Final mark for the answer. Yeah, well, they haven't said or equivalent, so maybe not as a fraction. I don't know. It's the same thing, but I guess as a percentage, you'd have to leave it as a number, wouldn't you? So that's probably why they've not said or equivalent. Yeah, I guess you'd have to put the actual decimal answer. It's just because in the mark scheme they give you like 5 different options because everyone would have done it differently, so you have to kind of try and figure out which option you went with. Okay. So to prove that two lines are parallel is they have to have the same gradient, but obviously in order to compare the gradients, they have to be in terms of y. Y has to be the subject. So you see the second one, the problem with this one is I'd have to rearrange it to get y as my subject, which is effectively just dividing by 6, isn't it? So I would divide across by 6. So 3 over 6 simplifies to a half anyway, and then just put it as 7 over 6. That bit doesn't really matter that much, does it? Yeah, exactly. 3 over 6 is a half. And then, so that's probably what I would do. And then I would just say, yes, they have the same gradient or something like that. Do you know what I mean? They referencing to the gradient. Or both of the gradients are a half or something like that. They have to also be the same positive or negative as well, technically. So yeah, that's literally it for that parallel lines. Just, do they have the same gradient, yes or no? What are the other statements? So they've given a mark for you have to rearrange it basically, which makes sense because how else would you know that they're parallel? For statement and equations which could be used to show the gradients of the line. So they've just given 2 examples. Both have a gradient of a half, or both have the same gradient, or both have the same x coefficients. That's fine. Yeah, you think I would probably stick with gradient. They have said x coefficients. I think it's just more obvious to say that they have the same gradient. They've also said here you could have technically multiplied the other one, the left-hand equation. You could have multiplied that by 6 to show that they have the same coefficient, but I don't know, I wouldn't think to do that myself, personally. Yeah, m represents gradient normally, doesn't it? When you've got y equals mx plus c. So that's the gradient, isn't it? So maybe that's what he means. Okay, next one, question 10. So Aaliyah bought a car in the first year after she bought the car. Its value depreciated at a rate of 23% per annum. In the second year she bought the car, its value depreciated at a rate of 19% per annum. At the end of the second year, the car was worth £10,914.75. What was the value of the car when Aaliyah bought it? This also, not necessarily in this case, but is compounding, isn't it? Not compound interest, because interest is obviously the context where you gain money and it increases. But you can also just use the same formula for a decreasing scenario. You've still got a percentage, you've still got, or you would have still had an initial amount, you still have a number of years. You would just put subtract instead of add. But this is also reverse percentages in that case, as next we're going backwards. So just so you're aware, if you see something where it says a car, maybe a boat, maybe a phone, and it's decreasing in value, that normally is also compounding. You can use the same formula, but obviously just reduce it, subtract it. So I guess there's different ways to do this depending on how comfortable you are with multipliers and things like that. What I like to do is I go, right, okay, we're trying to work out something in the past, backwards, aren't we? So I'm just going to say x is the value of the car originally. I like to think about it as what has happened in the correct order in terms of like an actual timeline. The first year, it depreciated by 23%. So if I think about my multiplier, think about the question we just did earlier. She increased by 3%, or she increased by 1.5%. So we did 100 plus 3%, didn't we? In this case, it's now 100 minus 23 because we're going down, we're reducing, we're losing value. So that would be 77%, wouldn't it? So my multiplier is 0.77. That will automatically take off 23%. Now what you can do is just then go, okay, for the second year, same thing, 100 minus 19 is 81%, so then I just times it by 0.81. That's what I did, just to kind of figure out what actually happened. You can obviously do it in a completely different way, that's fine, as long as we both get the same answer. And then I put that equal to obviously the value today, which is the 10,000. Do you see how now I've at least got an equation that I could figure out how to reverse? So you don't have to necessarily write it like this if you don't want to, but as long as we end up with the same answer at the end. Now you can just multiply those together if you want, or you can just divide it straight away. So what I'd probably do is the 10,914.75 divide by, what was it, 0.81 divide by 0. I think I would just type it like that. Just literally straight. You can do it in 2 separate steps if you want. I would just do it straight. Do you see how I've got this number, which kind of tells me, because it's such a nice number, isn't it? It's like not decimals, quite a nice rounded number. In my head, I'm like, yeah, that probably is correct, isn't it? That makes sense. 17,500. That's how I did it. As I said, as long as you get 17,500, that's fine. I don't mind. Like, they obviously don't really care how you've done it. There's probably different ways to do it, isn't there? As long as you've got 17,500, then I can assume that you've done it correctly. Okay, so yeah, that's how I would do that. Is A-levels hard? Yes. I'm not gonna lie. A-levels is brutal. Yeah, you don't even necessarily need the actual, well, technically it is the compound interest formula, but you just would put it to the power of 1 for 1 year, but obviously that makes no difference, does it? So effectively you could figure it out yourself really without the actual formula, but it is, just so you know, it is the same thing. Even though it's a decreasing scenario, you can still use the same logic from that formula. Any tips for maths A-level? Yeah, maths is brutal, honestly. If you're going to take maths, maybe take some other nicer subjects along with it. It's probably my best tip. I don't know, A-levels is hard anyway. It depends what you choose, but when I did maths GCSE, I got an A-star, which I guess now correlates to like somewhere between an 8 and a 9. Obviously I don't know exactly because I don't remember what like actual grade I got in terms of marks, and I found A-level maths hard. So I know that my school said you had to get at least a 6 at GCSE to do A-level maths, but I think that's still, I would say that's still quite low, to be honest. Yeah, A-level physics sounds even worse. I didn't do physics, but it sounds like anything like the really academic subjects, maths, any of the science. Well, do you know what? Biology wasn't that bad, but like chemistry, physics, I think those just sound horrific. Some people even do further maths, which is mental. Your 6th one doesn't do physics. That's random. Yeah, I hated English, so I obviously didn't do that. Dropped that immediately. Okay, so we've got here cumulative frequency. Actually, this is interesting because you didn't get cumulative frequency in paper 1, so I feel like there's a very, very good chance it will still come up at some point. So we've got, in an experiment, 60 students each completed a puzzle. The cumulative frequency graph shows information about the times taken for the 60 students to complete the puzzle. So for these 60 students, you can see they've given you the least time and the greatest time. And then on the grid below, obviously draw a box plot. So if they want you to go from a cumulative frequency graph onto a box plot, they will always give you these other 2 values because you can't read that off of your cumulative frequency graph. But the other 3, which is lower quartile, median, upper quartile, obviously you can use the graph to find. So we can always draw on these to start with. Just be careful of the scale. Sometimes it's really nice, the scale. This one's not a great scale, is it? Because you see how you've gone from 20 to 40. So do always just double check the scale. So for 24, it's actually going to be 2 squares along, not 4, isn't it? 2 squares along. It doesn't matter how tall or like the height of your box plot. You can do the lines as high as you want, obviously within the grid. So that doesn't matter. 96, again, be careful. So this is 90, so it's 3 along from here. Just double check all of the scales. So those are those first 2. We might as well write those down immediately. Now let's work out the median. So we've got 60 students. So for the median, we'd obviously, don't have to write this down necessarily. They've not obviously given you any space to work it out, but just so you can see, we obviously want to know halfway, 50%, which is 30. So on the cumulative frequency side, we need to go across that 30 and then down. So you can see that should be like an exact number. There shouldn't be a range of possible answers here. You should be able to see it exactly. So again, be careful of the scale. That's 50. I'd say that's 54 based on the scale. Now the scale actually does match up with the bottom one, so you can kind of make sure it's lined up underneath as well in the box plot if you want. So 54 for the median. And then obviously upper and lower quartile, you do basically the same thing, but we want 1/4 or 3/4. So that would be 15 for the lower quartile. Always from the y-axis across and then down. So that one's 42. So about there. And then obviously the upper quartile is, you can just take your lower quartile and times it by 3, because that's 3/4, isn't it? Or 75%, which is 45. And that looks to me to be about 64. Yeah, 64, that one was 42. And then you just complete your box plot. This bit's quite straightforward, isn't it? So you could still get this question because you haven't seen it already, have you, in paper 1? Obviously, you're going to draw a much nicer box plot than I am. But you get the gist. No, the lowest you have to take from what they've told you. Because if it was from the graph, then they wouldn't tell you, would they? You have to take it from here. Okay, so that was, what was that, 3 marks? That's quite a nice question, I think. It's the same every time. So question 12, the number of insects in a population at the start of the year n, they've said, is basically represented by saying Pn. Number of insects in the population at the start of the year n+1, so the next year, is represented by Pn+1. And then they've given you this formula. So what that means is to find out how many, how many insects there are next year, I need to take this year's population and multiply it by whatever k is. Now they've said then here that k is the constant value of 1.13. Don't know why they haven't just written it in the formula, why they've separated it, but anyway. So basically, effectively, think about it in terms of percentages. Every year, the population is increasing by 13%, isn't it? Every year it's increasing by 13%. I mean, you should get the exact values for the previous question. I don't think there's any kind of option as to not get the exact values. They don't normally draw it either, they just say fully correct and then they'll give you, so 24, 42, 54, 64, 96. As long as you've drawn on those points and then you've obviously got the correct box in the middle and then the other two are kind of like joined at the end, then that's what they want. But you can't get like a different value. It looks a bit like iteration, doesn't it? It does look a little bit like iteration, for sure. But I think it's not like a normal iteration question, is it? But it kind of looks like it. So sometimes you could see iteration with a context like this. But effectively, I was just looking at it almost in my head as like percentages. Do you see how that's effectively saying that they're adding 13% every year? If you think about the compounding we were just doing, kind of the same thing as well, isn't it, in that sense? So it's a bit of both of those topics, I'd say, compounding and also iteration. So find out how many years it takes for the number of insects in the population to double. So we've obviously not got a starting value or an ending value. You could also, in this case, you could do, as I said in the other ones, if you want, you could just start with 100. Yeah, you could start with 100 if you want, or you just look at the multiplier if you're confident with working with multipliers. You could do that as well. Again, there's kind of multiple different ways. You could say, let's say that Pn is 100. In order for it to double, it would have to become 200, wouldn't it? So you're doing 1.13 times 100. You could just do that if you wanted. whenever there's not a number, you can always put 100 in. That's what I tend to do. 100 times 1.13 is that. You could use the iteration if you wanted in terms of, let's do that. So you put 100 as my starting value, just put it as your answer there. And then you get answer multiplied by 1.13. That's the formula, isn't it? So obviously for after 1 year, it's 113, isn't it? After the second year, and you see what I mean? I'm going to keep going until I get to 200. No, what I would do, I think it's only 2 marks, which means it's 1 mark for your answer and 1 mark for your working. So I would probably just write down a couple of them, maybe. So like that was 100. No, it wasn't. That was 113, and then 1.13 times 113. What did that give me? 127. I think if you just wrote down 1 or 2 of them would probably be fine. You could obviously write down all of them if you just wanted to make sure you didn't lose count, because there's also that, isn't there? You might end up losing count of how many times you pressed it. I think when I did it, I just wrote down like these answers. I didn't even, like, maybe write that down first, the actual calculation, and then just write the answers from here. So 144. And then I'm just going to write it so I don't forget how many times I've pressed the equals button. 163, we're still not quite there. You see what I mean? Something like that. 184. And then it goes to 208. And then see how that's 1, 2, 3, 4, 5, 6 years. Yeah, so it's 6 years. Yeah, you could use the answer button and just write your answers. Yeah, I think that's okay. I would imagine that the markers are trying to at least find something where they can mark you correctly. Yeah, I would imagine so. 8 times, was it? Wow. In that case, you probably didn't need to write down 8 different calculations. I think that would be too much working out. It just depends if you want to not lose count of how many times you've pressed the button, because I probably would. So yeah, I would do that. You don't have to necessarily do it like that. You could just use the multiplier by itself, but I think it's easy to start with 100 and just go from there. Oh, as a practice paper. Yeah, I think there are some certain limits to what I would think would be reasonable for an actual paper. As you said, 8 years seems like kind of too far, doesn't it, almost? So then you've got part B. So the value of k actually increases year on year from its value of 1.13 in year 1. How does this affect your answer to part A? So if you think about it, we said originally that every year that it's increasing by 13%. Imagine it's increasing by more than 13% every year. So then to reach double, because that's what we were asked about, wasn't it? How long would it take to double the population? Would actually take less time, wouldn't it? You could say less time, fewer years or less years. My answer would be less or my answer would be lower, something like that. You could say I think one of the options in the mark scheme was like your answer is an overestimate, but I wouldn't actually think to say that. So something along the lines of fewer years, right? It would decrease the answer, yet that should be fine as well. Okay, so that's it for that one. So we've also got something with kind of what I'd class as like a coordinate problem. Again, I feel like I see this quite a lot. Not necessarily this exact question, because they can vary, but just some kind of something to figure out with different coordinates. That seems to be definitely something in paper 2 or paper 3. So A and B are points on a centimetre grid. A is the point with coordinates -7, 6. B is the point with coordinates 8, -5. Work out the length of AB. Whenever it says work out the length between 2 coordinates, it's always Pythagoras. So you can just use Pythagoras as it is. If you want to draw it, sometimes I find it's helpful to just sketch it out just so I can get a good idea. You don't have to, it's obviously only 2 marks. Sometimes I like to just give it like a really rough sketch. So that's -7, 6. So let's say A is over here, B is 8, -5. So B's like somewhere over here, isn't it? This is the line between them. Do you see how I could create a right angled triangle? Like there. You're just working with X and Y separately. And then that's a right angled triangle, isn't it? So from 8, where was it? It was 6. This is technically -5. So do you see how the difference is 11? And then across, we've got -7 to 8, which is a difference of 15. So effectively, it's just 11 and 15, isn't it? And then Pythagoras. So AB, I tend to write it directly. You can obviously start with the formula and then rearrange it afterwards if you want. But it's effectively just that, isn't it? 11 squared plus 15 squared, and obviously square root it to find AB. And then they've said to give it to 1 decimal place, so that would be 18.6. There's your answer now. Again, they have given a slight, well, kind of pointless really, but they've given a slight range of answers. I don't really know why. Anything between those two they've allowed. I guess that's, again, if you just didn't round it and you wrote down the whole thing, then they would also give you the mark still, even if you didn't round it. Okay, question 14. We have got recurring decimals to fractions, which I know that it did already come up, didn't it? In your paper 1. But still, might as well practice it. So you just put x is equal to this. Obviously try and copy it correctly. Now in this case, the only thing recurring is the 2. So we need to isolate the 2. So I would want to move my decimal place 2 more. So that would be 100x, wouldn't it? 100x to get 106, and then isolate the 2 recurring. Then I need a second version of that recurring decimal. Because it's the same digit recurring, I only need to basically multiply by another 10, don't I? So I'll use 1,000. 62, and then 0.2 recurring. And then you know where to go from here. You just subtract it, 900. Obviously, the whole point is that these cancel. You can always subtract this in the calculator if you want to, given that it is a calculator paper, but you should get 956. Divide it, and then you can double check in your calculator that it would simplify to that. But I think you could probably just make the leap, couldn't you? But it does simplify to that. So yeah, nice 3-mark question, but I know you've already had that question, so it's very unlikely that they will ask you again, isn't it? This one is capture recapture, which is really nice if you have the formula, if you know how to use the formula. Super easy. Easy marks. And actually 3 marks. I don't know why it's 3 marks, to be honest, but yeah. Okay, so Faiza is studying the population of rabbits in a park. She wants to estimate the number of rabbits in the park. On Monday, she captures a random sample of 20 rabbits in the park and marks each rabbit with a tag and releases them back into the park. On Tuesday, she catches a random sample of 42 rabbits in the park. 12 of the rabbits are marked with a tag. Find an estimate for the number of rabbits in the park. You might have different versions of this formula, but I just basically put it in the order of the numbers they've given, because from what I've seen, they tend to write it all in the same order every single time. So you do 20, you multiply it by the next number, which if you see in order is the 42, and then you divide it by the final number. That's how I kind of do it, just because they word it the same way every time. But obviously you might have a different version of the formula. You might need to rearrange it afterwards. It's fine, as long as you get the same answer. As long as you get the same answer as me at the end, then that's fine. 20 times 42 over 12, 70. 3 marks. That's it. Yeah, you could do it separately like that if you want. 20 divided by 12 times 42. That's fine. As long as you get 70, then yeah, it should be correct. So yeah, that's a really nice 3 marks, to be honest. Then we've got part B. So Albie is studying the population of rabbits in a wood. One day he catches 55 rabbits and finds that 40 of these rabbits are marked with a tag. Albie estimates that there are 50 rabbits in the wood. Explain why Albie's estimate cannot be correct. It's just more obvious than this. No, I felt like this was such a trick question, because I was like, this is so stupid, surely. Like, what do you mean he caught 55 and then he estimated there were only 50? Where did the other 5 go? They didn't go anywhere, did they? They're still there. So it's just it really kind of threw me because I was like, surely they can't ask something so bad as this. But it is like, why is his estimate not correct? Well, because he physically caught 55, so he already knows there are more than 55, isn't it? Like, but it's so stupid. It's just like, it does make you second guess yourself and just think, is that what they mean? Like, surely not. Surely there's like another reason. It is just that straightforward. Right, that he's wrong because for some reason he can't seem to count. I don't know. It's probably quite a good one to look at the options for the reasons. Let's look at the mark scheme. What question is this? 15. You see here, so they've got some acceptable answers. The sample size cannot be greater than the population, obviously, right? It's kind of stating the obvious, but then you just doubt it, don't you? Like, surely it can't be that. The population is greater than the samples. That's the same thing, isn't it? Just the way around. There are more than 50 rabbits because he caught 55, right? He has underestimated. Like, you can't say some of these things. You have to say literally like the most obvious thing. Well, no, because imagine he's caught 55. However, I don't know how they catch them, right? I don't actually know in reality what they do. Let's say he's got 55 in this like hutch, right? He's got this hutch, there's 55 there. And then he goes, oh, I think there's 50. How is that? Do you know what I mean? Like, how is that possible? So some version of, you know, well, if he caught 55, how is there only 50 in total? Like, that just doesn't calculate at all. So yeah, I thought it was kind of a stupid question, honestly. Question 16, we've got regions inequalities, but kind of the opposite way around. They've actually drawn them for us, and we need to find the original inequalities. So the shaded region shown on the grid is bounded by 4 straight lines. Find the 4 inequalities that define the shaded region. 2 of them are kind of nice to start with. I normally like to start with the ones that are like literally vertical or horizontal, because surely those are kind of the easiest ones, aren't they? So up here, we've got, just be careful which is X and which is Y. It's obviously at 6, this horizontal line, but it's not an X one, is it? It's Y is 6. So you've got Y and then you've got 6, but I need to figure out which direction am I putting my inequality. Again, it's kind of straightforward because I feel like you can see that the shaded region is below it. So in terms of Y, then it's less than, isn't it? Y is less than. I put equal to just because it's not a dashed line, so I put the equal to as well, but I don't know how fancy, like, specific they are about that. Yeah, find the equations of the lines and then put them into inequalities. Okay, so that's the first one. Then the other one that's, I think, quite obvious is this one here, isn't it? Do you see how that's at -3? And that's just vertical. So that's X -3. But again, is it greater than or less than? Well, because it's on the right side, it's going to be X is greater than -3, isn't it? Greater than. So you can already start with those two. I think those two are kind of the low-hanging fruits of the whole question. The ones that are maybe a little bit harder are the diagonal ones, but in that case, you're just trying to find the equation of a line, aren't you? So let's do this kind of, this one here, I don't know, the one that's going down. Let's do that one. Obviously, straight line graphs, just don't worry about the inequality until the end. We already said earlier, y equals mx plus c. Because you can see the grid, the graph, you can see where the plus c is. So that one's obviously +1, isn't it? We just need to know the gradient. So you can work out the gradient. Obviously, you could just pick out 2 coordinates, change in y over change in x. You can also just draw, because you can see it, you could draw like a triangle if you want to do it that way. Either way, we need to divide y by x, don't we? So I think I just drew like a triangle here. Tried to find some exact points. So the change here, do you see how, just be careful of the scale, that is a -1, isn't it? Is -1 because it's going down. And then the change in x is 2. So that's basically -1/2, isn't it? -1 divided by 2 is just £-1/2. So that's that one. Obviously now I want to convert it into an inequality. So the way that I imagine it is the shaded region, just think vertically, is it above the line or below the line? In this case, it's above the line, isn't it? So that means that it's y is greater than the line. Think of this bit as the line. Are we talking above or below the line? We're talking above, aren't we? So I would say y is greater than, obviously, or equal to all of the rest of it. And then just do the same for the other one. So the other one, like the steeper one, You can see it's crossing at 6, so we've already got that. Normally I'd find the gradient first, but seeing as we can see it, you might as well write that down. And then this one was a bit hard to find the gradient just because the exact coordinates I think were quite far apart. You can use this too. That was a horrible line. So change in x is 1, change in y, what's that, 3? It's going up. So 3 divided by 1 is obviously just 3. The gradient is 3. Again, then we put it into the inequality. Are we talking above or below the line? It's not quite as obvious this one, but it is above, isn't it? Technically it's above the line. So again, just copy the same. Y is greater than 3x plus 6. So there we go. There's your marks. Now, probably good to see the mark scheme just so you can see where the marks came from for that one. Obviously, those are the answers, right? That doesn't match up with this. That's just the list of answers. So you get mark 1 for just saying y is 6 or x is equal to -3 for the straight line ones. Like, well, they're all straight lines, but for the vertical, horizontal ones, even if you don't put the inequality, you get a mark for that. You then get a mark for writing the equation for the other two. Okay, so let's say if you didn't even write any inequalities, you just found all of the equations of the lines. If you got all 4 lines, then you would get 3 marks out of 4. And then at the end, you just get 1 mark for putting the inequalities in. So that's actually not that bad. Because I feel like the hardest bit is the inequalities. You could definitely figure out the equations for sure, just on their own. So yeah, that's quite nice actually. 3 out of 4 marks if you just got the equations. And it's just y equals mx plus c, so that's not too difficult. So yeah, 4 marks hopefully in total for that one. Question 17. So I think this was the one that was a little bit more difficult. So we've got the diagram shows 2 similar solid triangular prisms A and B. So you can see B, we actually do have some information about it. So the volume of A is 58.806 centimeters cubed. The volume of B is 1587.762 centimeters cubed. The cross section of each prism is a right-angled triangle, which you can see. From prism B, the length of the base of the triangle is 8.1, and then the area of the triangle is 43.72 centimeters squared. Work out the height. So the relationship was here, that they are similar. That was kind of the link that we needed to pick up on. They are similar solids. I think there's multiple different directions you could go about doing this. But what I did was I was like, okay, they're similar, which means there's a scale factor. Now, the only thing we can compare, the only thing where we have a value for A and a value for B is the volume, isn't it? We don't know anything else about A. We don't know the area. We don't know like the base or anything. So I use that to find a scale factor, but obviously that's the scale factor of the volume, don't forget that. Scale factor volume, right? Now you can divide it whichever way around you like. I like to always, I don't know, I just tend to do the bigger one divided by the smaller one. I don't know why, I just feel like the answer is normally a nicer number, but you could do it the other way around if you wanted. I just think it's more complicated if you did. So I would do that. So let's see what that gives us. So what's that, 1587.762, obviously make sure you've put it in correctly. Nope, don't miss out the 6. Do you see how I get a really nice number there? 27, which also, if you think about volume, it's cubed, isn't it? It's 3D. 27 is also a cube number. So that's why they've done that, and that's why I like to divide it that way around. So I then went, well, they've asked me to find the height of this prism, which is a one-dimensional measurement, isn't it? One-dimensional. So to find the scale factor for just like the height, I would cube root the volume one. Just simplify it like that. Cube root that, which obviously, hopefully you know, gives us 3. So what we're saying is that in terms of just one-dimensional measurements, in terms of the base, in terms of the height, I guess also in terms of like the length, technically, prism B is 3 times the size of prism A. That's what we're saying. So how do I actually use that to work out the height? Well, I've used this information, haven't I? I haven't used this information down here yet. So I think what I did from there was I worked out the height of B, because I've got the area and I've got the base, haven't I? So obviously if you think about area of a triangle, half base times height, or base times height over 2. Let's see, 8.1 times the height, technically over 2, equals 43.74, doesn't it? Do you see how I've got an equation there? And then I could just rearrange that to find the height. This is the height of B. I could just rearrange that, couldn't I? So take my 43.74, times it by 2, and then divide it by 8.1, or however you've obviously done the formula. So the height of B is 10.8. Height of B, 10.8. And then my last step is, because I now know that technically prism A is 3 times smaller in terms of like a height, I just divide that one by 3. Which I think gave me 3.6. Obviously you can put that in the calculator as well, but it gives you 3.6. Now you might have gone about it in a different way, that's fine. If you've got 3.6 at the end, then that's it. That's fine. If you did a different method but you got the same answer, then, you know, mathematically it's probably sound. So that's what I did for that one, but I thought that one was a little bit harder, I don't know. Get your head around it a bit. Or at least see an example, and then from there you can kind of recognise it next time. Okay, so 4 marks, that's quite nice for that one, 4 marks. Question 18, so we've got, here is a triangle, you can see immediately it's a scalene triangle, we've got some angles, we've got some sides, we kind of know where this is leading to. The specific question though is work out the area of the triangle. So yeah, trigonometric area of a triangle, obviously that formula is on your formula sheet, so just refer back to that if you don't already know it, but it's basically half AB sine C, so you can label it if you want. Obviously the angle would be C, and then A and B are just the sides around the angle, so it doesn't really matter which way around you put A and B. And then yeah, that's why I guess why it's only 2 marks, because you're literally just substituting into a formula, aren't you? That's it. There's not really anything else to know about that. So I would just type this into my calculator. 11.2 times 4.3, just make sure we get all the numbers right. Sine 118. Now I've got 21.26. Technically they have said round it to 3 significant figures, so obviously that would technically be 21.3, but again I'm assuming they're probably not that bothered by the rounding as long as you've got that 21 answer. But that's it. So that's a really nice one. We've got another nice one as well. If I can scroll down, that'd be great. There we go. So we've got solve this quadratic. Now you've got 2 options here. You can obviously try and factorize it. They haven't mentioned to round your answers, so I'm assuming that we probably could factorize it. You could also use quadratic formula just straight away if you wanted, because it is calculator. I think I used quadratic formula just purely because I couldn't be bothered to try and factorize the 6x squared, but it, based on my answers, yeah, you can see that you can factorize it. So whichever of those 2 methods, you could even complete the square and solve it that way, but I probably wouldn't, but you can. So I just use quadratic formula personally. That was just me. Obviously that's on your formula sheet anyway. So minus b plus or minus square root of b squared minus 4 times 6, or a, times c, and then over 2a. Luckily there's not really a lot of negatives we need to worry about here, but sometimes you have to worry about that, don't you? If the b is already a negative. So I'll start with the plus, and then obviously afterwards you can come back and do the minus. Sometimes I just work it out for myself, like as in sum of parts of it. That's just me. And then like, so for example, I've worked out like pieces of it myself. So you can see I've got 2/3 for one option, which would, you know, factorize, would have come out of a bracket quite nicely. Or go back, don't delete the whole thing, just use your back arrow, and then skip to the plus and make it a minus. Minus 3/2 or minus 1.5 if you want to write it like that. I would just leave them as fractions though. So those are your answers. 2/3 or minus 3/2. As I said, you could have factorized it. If you got the same answers, then that's fine. It doesn't really matter what method, because they haven't specified what method to use. So yeah, another nice 3 marks. Okay, question 20. I mean, immediately looking at this, it's making me think it's probably 3D trig. So you've got a 3D shape and then there's some kind of sides and angles. So let's label it because I haven't already done that. AD, where's that? The top one is 9, which obviously means all of these other FE, GH, BC are also 9. FD is 13, so I'm going to draw that on. You can obviously always draw and label and annotate any diagrams if you want. So that one's 13, which also means G to C is also 13. I guess also the other way around as well, isn't it? A to E would also be 13. And then they've said the angle GHF is 49. Where's that? GHF. So that's on the base of the, not the base of the triangle, but on the base of our rectangle, but it creates a triangle, doesn't it? So that's why I would draw that one there. It's quite hard to annotate and see it properly, but anyway. That's 49. Okay, work out the sides of angle FAH. So F to A to H. So I'm going to draw also a line from A to H. This one's, I think, quite complicated just from the way that it's laid out, but you're basically, when you've got 3D trig like this, just try and picture still 2D triangles, 2D right angle triangles. So just in maybe one's on the base of the on the base of the shape, one's like stood up in the middle, like the one you can see FAH as a whole triangle just stood up vertically through. It's never going to be a triangle that's like slanted, if that makes sense. It's always going to be, you know, either horizontal or vertical. So to work out the angle, kind of need to overlap here, don't we? So let's get a different colour. This angle here, I need to know, obviously, information about that triangle. Maybe it's better if I do it as a colour. Let's label it as a colour. So the pink triangle is the one we're looking for at the end of this. That's the whole point. Sometimes, I say 3D trig, sometimes it is just Pythagoras as well. That can also happen, right? So it's not just trigonometry, literally. Do you see how that's created just an upright triangle? Try not to get confused with the 49. The 49 is on the base of the shape. It's not like stood up, right? Okay. So let's see, what can we do here? I obviously, in order to find an angle of the pink triangle, I need to know two sides of the pink triangle. So then you can figure out, well, which two sides could I maybe work out? Based on the information they've given me, I do know 9 centimeters up here, so 9 is also down here, isn't it? Also back there as well. Technically, GH is also 9, isn't it? That type of thing. What else do we know? I think we could work out, yeah, we could just work out F to H, couldn't we? Because we've got a side and we've got the 49. If you look at the triangle FHG, that triangle at the base, that is also a right angle triangle, isn't it? So I would start with that probably. I would work out F to H using trigonometry because I've got an angle. So what have I got that's relevant? We've got the adjacent, the 9 is the adjacent, and I want to know the hypotenuse. So that is cos, isn't it? So get my triangle. I'm looking for the hypotenuse, so cross that out. So do you see how I would have to do 9 over cos 49? So 9 over cos 49, it's obviously going to be loads of decimals. 13.718 ... We'll come back to that later. So I've now got one side of the pink triangle. I obviously want another side, whether that's going to be AF or AH, it just depends what information I've got. So I have used, technically, the 9, haven't I? I've used the 49. The thing I haven't used is this 13, isn't it? You can always do that. If you're not sure what to do, just go through and tick off the information you've already used and see what's left. Maybe that will give you a clue. So I know this diagonal here, FD is 13. I also happen to know the base of that triangle is 9, or technically you could look at the triangle vertically if you wanted, the one at the top is 9. So that means I could use Pythagoras to work out either AF or DE or whatever. It's the same side, isn't it? So let's say we'll look at this top triangle here, shall we? AFD. I've got the hypotenuse, I've got one side, I want to know the other side. So that's Pythagoras. Now just make sure you lay it out properly because I've been given the hypotenuse. It's technically a squared plus b squared plus c, well, equals c squared, isn't it? C is always the hypotenuse. So that's 13 squared. A and B doesn't really matter, so let's say we don't know what A is and we know that B is the 9. Do you see how I'd also have to rearrange that, wouldn't I? Yeah, George, the answer is 56 at the end. That's fine. So grab my calculator. I would rearrange it. Obviously 13 squared minus 9 squared, or you could type in 81 if you wanted, is technically 9.38, but I would probably leave it as 2 root 2 because this isn't my final answer yet, is it? Let me label that correctly. So that was AF, 2 root 22, just so I can have an exact number. Okay, so finally, 2 root 22. Now let's look back at the pink triangle. I want to find the angle. I've got two sides. I've got the 2 root 22 and I've got this down here, which was, what was that, 13.7-ish? I know it's really messy to look at. It's really hard. You could always, obviously if you annotate it, do it in pencil, and then you can start rubbing out things that aren't necessarily relevant. So for the pink triangle, we're using trigonometry. I've got the opposite and I've got the adjacent. So just be careful, because before, when we did FH was a hypotenuse of the other triangle, but in this case for the pink triangle, it's now the adjacent. So just be really careful with that. So I'm obviously going to use tan. For tan, I know that it's opposite divided by adjacent, isn't it? So tan of, what was the angle? F. Oh no, I've listed the wrong angle. Hang on. I was just thinking that didn't make sense. The angle's in the top corner, isn't it? There we go. I was just thinking that didn't make sense. Swap them around. I think it is still tan. This one's now the adjacent, this one is also the opposite. So either way, we're still using tan, but obviously make sure you have got the right angle. I think they've done that deliberately because normally it's like one over here, isn't it? They've done this top corner for whatever reason. So carry on with tan. We know that we're trying to find an angle, tan of FAH. Opposite, 13. Remember that it was a decimal number, so I'm probably going to bring that back on my calculator if I can, over the adjacent, which I have got the exact number for. I'm just going to rewrite it in because I like to have the exact number. I'm just going to redo that so I can get all the decimals again. So that's my 13 number, isn't it? So because it's an angle, we do need to do inverse, a tan inverse of the opposite, which was the 13 number. That's just my answer there. And then over the adjacent, which was 2 root 22. I've just tried not to round anything too soon. And then this is my exact answer, but obviously they've then said, give your answer correct to the nearest degree, so that would round, wouldn't it? So 55.6, but obviously that would round, as Georgia said, to 56. So down here, my actual answer, I'm going to put 56. But again, they have said anything between 55.6 and 56, so if you didn't round it, they would still give you the answer. They would still give you the mark. So yeah, 3D trig there. Question 21. The graph below gives the volume in litres of water in a container t seconds after the water starts to fill the container. Calculate an estimate for the gradient of the graph when t is 17.5. You must show how you get your answer. I'm pretty sure you already got this in your paper 1, so it's very, I would say, very unlikely they'll ask it again. But obviously we'll just go through anyway. So this is the one where you need to draw a tangent, isn't it? Because you want to find the gradient of a straight line. So tangent at 17.5. Now to find the gradient, you obviously have to pick two coordinates. So I like to, you don't have to do this, but I like to use the exact coordinates that they've given me. So 17.5 is here, isn't it? So before I draw the tangent, I like to just read off, because it's quite an exact coordinate, isn't it? You see that? That's, be careful of the scale. I would say that's 10.5. It's not 11. It's 10.5. So I just like to write that one down first, then I'll draw my tangent, because otherwise once you've drawn your tangent you can't really read the coordinate very well. So there will be a range of possible answers, so just depends, because obviously your tangent will look different to my tangent. Is that right? Something like that, isn't it? It's just touching at 17.5. So I've got one set of coordinates. I'm now going to choose from this line another set of coordinates that I can see that are fairly solid. So I would probably do 20, and then what's that? Is that 13? I think that's 13. And then obviously change in y over change in x. So 13 minus 10.5 over the 20 minus 17.5. And I'm obviously going to now put that into my calculator. and that gives me 1. Now, as I said, they will give you a range of possible values. So they have said as long as you get something between 0.9 and 1.2, I got 1. You might obviously get, it's very likely you'll get a different number than me, then that's fine. But leave the tangent there, don't rub it out. Leave it there. Okay, then we have to describe fully what the gradient in part A represents. So relating to the context basically is what they want. Now a gradient generally is a rate of change. And then they just want you to relate it to the context. So what I would say is you could say it's the rate of change of volume. Like you could literally just say that. They obviously have other examples in the mark scheme, but rate of change of volume, that's kind of, I guess, the most standard answer, because volume is gradient is always the rate of change. And then in this particular context, you just say whatever the y-axis is, which is volume. But, you know, there are multiple different answers for this. As long as you've referred to the context, I think is what they want you to do. I think if you just said rate of change without the volume, I'm not sure they would give it to you. Okay, so then 22, we've got functions. Now I think you've got functions in paper 1, so whether that would come up twice, I don't know, I think probably unlikely. So we've got f of x is the cube root of x, and then g of x is 2x plus 3. They've told us that h of x, so this other function is the same thing as the composite function of f of g of x. We then need to find the inverse of that other function. So it's kind of 2 steps, isn't it? First of all, I'm going to find the composite function. Once I've done that, I'm then going to invert it. So remember, it always goes backwards. So g would go into f. So that's the function of h would be the cube root of the whole of g. So that's pretty straightforward. There's nothing really to rearrange there, is there? Now I want to invert it. So I like to put y. You might want to change or swap the x and the y immediately. I tend to swap it at the end. Doesn't really matter. So in my case, I'm going to make x the subject. If you swapped them immediately, you would make y the subject. So I'm obviously going to cube, and then that opens it up. I can then take away the 3. If there's any kind of plus or minus, just move that first before you start dividing. And then obviously I'll divide by 2. And then I would just swap that at the end. Right, so obviously it's not y, it's x cubed minus 3 over 2. That should be your actual final answer. Okay. But yeah, we said functions have already come up, so hopefully they won't come up again. I think we've got 2 more questions now. So at some point we were waiting for upper and lower bounds, weren't we? And also I think speed, distance, time comes up a lot anyway in papers 2 and 3. And I don't think you got it in paper 1, so yeah, that will definitely come up. In this case, it's just come up as both in the same question. So a race is measured to have a distance of 10.6 kilometers, correct to the nearest 0.1 kilometer. Sam runs the race in a time of 31 minutes 48 seconds, correct to the nearest second. Sam's average speed in this race is v kilometers per hour. That's the first thing as well to consider. They've given us minutes and seconds, but the speed is in terms of hours, so you have to consider that as well. By considering bounds, calculate the value of v to a suitable degree of accuracy. Whenever they say by considering bounds, most of the time it means you need to find both. So for the speed, the upper bound and the lower bound of the speed, and then you'll choose a number that matches kind of both of those answers at the end. So it's 5 marks, it's just a lot of working out basically. So we obviously want to work out the upper and lower bounds of the distance and the time first. You can lay this out however you want. I like to lay it out. I don't know, for some reason I just like to visualize it like this. You don't have to obviously do that. 10.6 in the middle, so therefore my lower bound is like half of this, isn't it, less? So that would be 10.55. And then obviously the same amount but above, so 10.65. You can obviously lay it out differently. The time, 31, I'll just put m, 48. So then upper and lower bounds, it's to the nearest second, so half a second below, half a second above. 31 minutes 47.5, and then 31 minutes, oh, don't need to write that, do I? 48.5 seconds. So lower bound, upper bound. So that's the first thing. Then you've got to figure out, well, what was my actual calculation? Speed is obviously distance over time, isn't it? So we're dividing. So let's do the upper bound of the speed first. They've called it v. Let's put v. Is distance divided by time. What do I need, though, to get the biggest possible answer? Because we're dividing. Remember, when you're dividing or you're subtracting upper and lower bounds, you have to have one of each. It's not just both upper, both lower. It's one of each. So just think logically about, how can I get the biggest possible answer? Well, I would need the biggest possible numerator, and I would need to divide it by the smallest possible denominator. So the biggest possible numerator is obviously the upper bound for the distance, and then the lower bound for the time. Again, you don't necessarily have to write that, but I'm just kind of demonstrating. So the upper bound for the distance is 10.65. Now, we obviously have the issue with the time, don't we, that we need to divide by how many hours that is. So you just need to convert this from minutes and seconds into hours. I think there's different ways, but the way that I thought to do it was I did 31. Let's convert it all into seconds first. So times 60 plus, now I'm using the lower bound, so I'm going to add the 47.5. That's how many seconds I've got. I obviously want hours, right? So I need to divide that by 60 to make it into minutes again, and then also by 60 again to make it into hours. You obviously get this really horrible decimal, 0.52. Well, I guess for my working, I might just write down the 31.47.5. So they know which one it is, but obviously I'm not using that in my calculation, right? I'm using the hours. So I've got my answer here. So I can just do 10.65 divided by it, and then I'll put answer. Only once, answer once. So for the upper bound of the speed, you should get something along the lines of 20.0996 ... I like to write down a good few decimal places, at least 3. Just because then I can compare them both at the end. I'd probably just write the whole thing down, to be honest. So that's the upper bound. Obviously then the lower bound is just the opposite, isn't it? So that would be the smallest possible distance, numerator, divided by the biggest possible time, or denominator. So just swap them. 10.55 over 31 minutes, 48.5 seconds. Again, I want to convert that into hours though, so I'm going to go through that again. 31 times 60, add 48.5, and then divide that by 60, divide it by 60 again. Obviously not a nice decimal, but that's fine. And now I can divide 10.55 by my answer, and I get 19.0044 ... So you should get those two values. 44538. Okay, that's the bulk of the work. Obviously now they've said calculate the value, so one value of the speed. So look at both of these, and you basically just have to decide what number they both would round to. Now sometimes it's just a whole number, sometimes it's like a certain number of decimals. That's also fine. It depends on the numbers, right? In this case, I think the easiest thing to say is they both round to 20, don't they? So there's no decimals in this one. They both round to 20, and we have to give a reason as well. So I would put V is 20, what was it? 20 kilometers per hour. And then you have to say why. And the reason why is always based on what you rounded it to. So as both are 20 when, and you say how you rounded it. So it could be to the nearest whole number. You could be, in this case, also to 2 significant figures. Whatever you rounded it to, I'm just going to put 2 significant figures. But also, I guess it's the nearest whole number. You could have said that because they both are 20 when rounded to the nearest whole number, or to 2 significant figures. Or if you had one with decimals, you would say how many decimals you rounded it to, right? So you just have to kind of make that decision at the end based on what they both kind of round to. But I think, yeah, a lot of details, but not too difficult for 5 marks if you know what you're doing. Now the last one, I think this was actually quite a nice one as well. Question 24, it is 4 marks, this one. So a circle has equation x squared plus y squared equals 12.25. The point P lies on the circle. The coordinates of P are 2.1, 2.8. The line L is the tangent to the circle at point P. Find the equation of L. Now they have specified to give it in a specific format, but we will obviously worry about that right at the end. This is a really nice question. It's just find the equation of a tangent, which is a really straightforward method every time. So normally when you find the equation of a tangent, you cannot find, obviously the equation of a tangent is a straight line, so this is what we're looking for. We want the gradient, we want the plus c. Now normally if you can't see it, which we can't in this case, you need to find the gradient first. So to find the gradient, we've obviously seen multiple times in this paper, changing y over changing x, we need two sets of coordinates. The problem now is that I only have one set of coordinates on the line L. So what you have to just remember is when you've got this circle, based on this equation here, that tells me the centre is 0, 0, because it's just x squared, just y squared. So the centre is 0, 0. So what I could do is find the gradient of the radius, obviously because the radius touches the centre and also touches the circumference, so it would touch at P, wouldn't it? So I would do y, you don't necessarily have to write the zeros, but technically we're minusing 0, aren't we? And that would give me, I think that gives me, I would leave it as a fraction, if I were you, 4/3. Now, think about circle theorems. We know that the relationship between the radius and the tangent is that they are perpendicular. So to find the gradient of the tangent, I just need to do the negative reciprocal. So the negative, because this one was positive, obviously if it's already negative, you make it positive, right? You just swap the symbol and then you flip, that's why I said leave it as a fraction, flip the fraction upside down. So we've got negative 3/4. Okay, so now I'm going to input that into my format for a straight line. Y is equal to negative 3/4 x plus c. The last thing I need is the plus c, the y-intercept, which is where you just have to substitute in one set of coordinates that are obviously on the line. So I'm going to substitute in 2.1 and 2.2, just make sure you get them right around, because obviously y comes first here. I'm obviously going to use my calculator to work that out. So I've got negative 3/4, or no, we don't want to have our answer button. Negative 3/4 is the same as 0.75, isn't it? Times 2.1. And then I want to add that to the other side, don't I? Or in my calculator, I can double subtract it. So either way, you should get 35/8. I would leave it as a fraction just because of the next bit we're going to do at the end. So c is 35/8. So then if I rewrite my whole equation with now the number for c, I've got y is equal to minus 3/4 x plus 35/8. Now, that is obviously the equation of the tangent. However, if you look here, they have specified they do want it in a specific format. Sometimes they ask that, sometimes they don't. So all we need to do is, if you see here, ax plus by equals c, where a, b, and c are integers. That's the main thing. So that's why I said leave it again as a fraction, because to make these whole numbers, they've deliberately chosen these numbers, right? Because you see how one denominator is 4 and one is 8. They're multiple. Well, one's multiple of the other, one's a factor of the other. If I just multiply across my equation by the biggest denominator, which is 8, it will make them all whole numbers. So obviously you do get 8y, that's fine. Just be careful here with the 3/4. You can obviously put it in the calculator if you want, because timesing it by 8 is going to not only cancel out that denominator, but it's also going to double it, isn't it? So it's 6 or minus 6x plus 35. And then the last thing I just need to do is make sure I've got, do you see how they've got x and y on the same side? So I'm just going to add the 6x. 6x plus 8y equals 35. That's your final answer, just that formatting at the end. Okay, so just be careful with that. In order to find the tangent, it's normally that same exact method every time, but just be careful if they've asked you to specify it, do a different or a very specific format at the end or not. Sometimes they don't, sometimes they do, just double check. So yeah, I tend to work with fractions as much as I can, because I think it's easier not only for the negative reciprocal in terms of the gradient, but also in terms of if you do need to change the format to whole numbers, you can quite clearly see how to cancel out the denominators than using decimals. So yeah, anyway guys, that is all of the paper. This was November 2022, paper 2, higher tier obviously at Edexcel. Wednesday we will do the November 2022 paper 3, because the paper 2 topics and paper 3 topics are basically all the same. There's not really a very clear distinction, I don't think, between the two. So I think it's best to practice both calculator papers just generally, especially because paper 3 is so close after paper 2 anyway, isn't it? So we're going to go through paper 2 and paper 3 for each of these years, going backwards in time, from November 2022 backwards. And yeah, that's basically it. So thanks for watching this video. Obviously you can see this later on if you want to come back to it. It will upload onto my channel anyway. And if you want to come to the next one, as I said, it'd be Wednesday, same time, 7 o'clock. Also Thursday at 7 o'clock, we'll also do another one. So every Monday, every Wednesday, every Thursday at 7 o'clock are the higher tier Edexcel papers.